Okay, so we are going to take some time today to talk about section 20-1, which is the concept of Pythagorean theorem. And my guess is you guys have probably done this before, so I'm hoping that it's review. The reason that we paused to play with radicals, learn how to simplify them again, was because we need to be able to use radicals with something called Pythagorean theorem and some additional things that we're going to work on in the next few chapters. We aren't walking away from radicals. We're going to keep practicing how to simplify them, but now we're going to have a purpose to using those radicals. So the first thing that I want us to address, we're going to draw a triangle on our paper. Now this triangle is going to be a special type of triangle. So my question for either my Zoom or my in-person people, when you guys look up at the screen, what does that little box down there tell us about this triangle? Ah, it's a right angle. And a right angle is 90 degrees. So we have a right triangle. This concept of Pythagorean theorem works for right triangles. Doesn't work for scaling where all three sides are different, all the angles are different, they're not 90. It doesn't work for isosceles. It has to have a right angle. If it's got a right angle, we are happy. If it doesn't have a right angle, you might actually be happier because you can't do the problem with what we're looking at today. Please note, you won't get any of that kind today. So we're going to focus on this concept of Pythagorean theorem. By chance, does anybody remember what Pythagorean theorem is? It's okay if you're like, no. You guys might have seen it looking like this. Does this a squared plus b squared equals c squared, does that sound or look familiar? And it's okay if you're like, nope, it's totally fine. And especially with such a weird world we've been in for the last year, maybe you did, maybe you didn't see it. That's all good. So here's how Pythagorean theorem works. Underneath this a squared plus b squared equals c squared, would you guys please write down some words with me? We're going to write the word leg and we're going to square it, which seems weird because how do you like square a leg? Just write it down. Plus leg squared equals hypotenuse squared. Hypotenuse is a huge word. We're going to abbreviate that real soon. Do you guys know what the word hypotenuse means when we're talking about a triangle? Okay. The hypotenuse is going to be the longest side of a right triangle. So let's jot down a little bit about this hypotenuse word. And from here on out, I'm going to abbreviate that as HYP, bless you, because nobody wants to write that 1,000 more times. So the hypotenuse is going to be the side opposite.
These are the worksheets I'm using next week.
Awesome, thank you.
You betcha.
Ooh, those are good. I like it when he works ahead and he gives me stuff. That's awesome. Okay. So the hypotenuse is the side opposite the right angle. And as Grace shared, it is the longest side of a right triangle. So once you're caught up with my writing, I want you guys to take a look at the right triangle that we all drew. So we're going to label this right triangle in terms of A, B, C, or leg, leg, hypotenuse. So I want you to focus on the right angle, and I want you to go directly across from the right angle. That is our hypotenuse. It's going to be the longest of the three sides. Let's see if we can get you to see that. Hang tight, make the equipment happy. So the hypotenuse is the longest of the three sides and opposite the right angle. And we often like to label it with the letter C. So in this formula where you see C squared or hypotenuse squared, it's talking about that side opposite the right angle. The other two sides that come together to make the right angle, we call each one of them a leg. And you get to name one A and the other B, and it doesn't matter which one you name as A or B. A and B, the two legs, make the right angle. So it's just important that we make sure that this all works. So what's really cool about the concept of a right triangle is that their legs and hypotenuse have this shared relationship. That if we can say A squared and B squared added together equals C squared, then it's a right triangle. So I want to give you guys an example, but I'm hoping I haven't moved too far too fast. We're ready. I'm going to get my example ready and I'll scoot it up so you can see it in just a second. Okay, so here's our first example and our first question. Do the lengths form a right triangle? And so I'm going to give you some numbers. And we might need access to a calculator for these. So these are going to be three lengths of a triangle, three sides. We want to know if this makes a right triangle. So the first thing we're going to do, we've got to identify which one of the three has to be the hypotenuse. Well, the 15 has to be the hypotenuse because it's the longest of the three sides. And so that number is going to be totally on its own. So here's what we're going to do. We're going to take the two small numbers, we're going to square them and add them together. And then we're going to ask ourselves if that is equal to the longest side squared. So I will gladly be your calculator. 9 squared, that's 81. 12 squared, 144. 81 plus 144 is 225. So I'm just squaring the values. 9 squared, 9 times 9. 12 squared, 12 times 12. And I totally cheated and used my calculator to add them together. We need to know if that's going to be equal to 15 squared. Well, 15 squared is 225. Hey, they are equal. So our answer is yes, we have a right triangle. Questions on that example? Let's do another one like that. So I want to know, do we have a right triangle? It's actually a yes or no question. So let's talk about 3, 7, and 2. Let's find out if 3, 7, and 2 are a right triangle. Okay, first, I need your guys' help. Which one of those numbers has to be the hypotenuse if it's a right triangle? 7. So because it's the biggest one. So I always like to circle that hypotenuse number and kind of like identify it. So our task is to check, does this Pythagorean theorem work? So take the two smaller sides and let's see if that's going to be equal to the bigger side squared. So 3 squared is 9, 2 squared is 4, 9 plus 4, that's 13. Do you guys remember what 7 squared is? 49. That's not going to fly. Ooh, you couldn't see that. 13 and 49 are not the same number. And remember what 7 squared means. It's not 7 times 2. It is 7 times 7. So this is not a right triangle. I'm going to pause for a second. Please let me know if you have any questions on this style question before we move to the next style question. And if I write too fast, you guys can tell me. You won't hurt my feelings, unless you're mean about it. That'd be rude. You guys ready? Okay. So new example. I'm going to tell you guys that we do have a right triangle. So I'm going to draw my right triangle. I'm going to go this direction this time. That clears up. Now I'm making up these questions, so I have no idea. Actually, you guys can help me. Would someone give me a number? It needs to be a whole number. I don't want any negatives, no fractions, no decimals. Just a number. 10. Thank you. So I'm going to put 10 up there on the top. I need another number.
Maybe more than 10?
Sure.
14.
Okay. I'm going to put my 14 over here on the side. Please note, triangle is not drawn to scale. First, I don't draw well. Second, I don't do scale. Okay. So our directions here are to find the missing length. So find the missing side. But I'm going to add to those directions, which are actually going to change the directions on our assignment. I want exact answers. Now we need to know what the heck that means. Exact answers means no decimals. Exact answers means simplified roots. So here's our process. We know this is a right triangle. Because it's a right triangle, the lengths of all three sides, they are going to work with Pythagorean theorem. So our job right now, before we get into how do I find that missing side, we have to decide if that third missing side is a hypotenuse or a leg. So looking at this triangle, because it's the side opposite the right angle that's missing, that I'm going to label as the hypotenuse or the letter C. So we have to know what the name of our side is that's missing. It's the hypotenuse. So here comes our task. Our job is to take the two legs and square them and put a plus sign in the middle. And then set that equal to our hypotenuse squared. I don't know what the hypotenuse is. So I'm going to name that variable c, because that's what we call our hypotenuse. And then our job is to use a calculator and keep going. So I'm guessing you guys know 10 squared. 10 times 10 is 100. 14 squared is 196. So hopefully we can see that on the calculator. Oops, if I hit enter, we can see it on the calculator. So 196. 100 plus 196, that's 296. And that's equal to c squared.
But do we still have to figure out what C squared is?
Yeah, we're not quite done yet. So this is where square roots finally get used. We have to take the square root of both sides because square roots eliminate squares. And so now we have c equals whatever the square root of 296 is. So I'm going to pause. We are not done. Do you guys have questions on the setup and the squaring? Because here's where the work comes in. We have to figure out if we can break down 296. So I'm hoping you guys can see that. Maybe if I turn on the light, maybe that's a little bit better. So 296, it's even. So I'm going to break out a 2. And it gives me 148. So I'm going to circle my 2 because it's prime. Okay, 148 is even. So I'm going to break out a 2. And that gives me 74. 74 is even, so I'm going to break out another 2. And then it gives me 37. So guys, this is having us practice what we did all last week with those roots. Okay, 37. 37's prime. Nothing's going to go into 37. If you're thinking, what about 3? Nope, 3 won't go into 37. What about 9? No, 3 won't go in, 9's not going in, 5's not going in, 7, it's prime. So I'm going to circle that. So now our job is to clean up this mess. We've got a 2, a 2, and a 2, check, 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 and a 37. Out comes a 2. The 2 and the 37 stay inside. When I put it back together, I get 2 root 74. And we just found the length of the hypotenuse. So notice how I didn't just take the square root of 296. I simplified it. No decimals. Simplified roots. That's what I want to see. So I need to know what questions you guys have on this example. Because I've got one more that I want to do, and then I think we'll be good. Taylana, go ahead. Yes, absolutely. Okay, let's do another one. So I'm going to scoot this up. So new example, same directions. We need to find the missing side. So let's go with this right triangle. And let's choose maybe some smaller numbers this time. Not that there was anything wrong with what we did. Those were good. Let's choose numbers smaller than 10. So would someone please share a number with me? I heard a 7 and a, did I hear a 3? Okay. So let's put the 3 kind of down there on the bottom. And I want the 7 to be across from the right angle. So first thing, that 7, that's our hypotenuse because it's across from the right angle. That means this side that's missing, that's a leg because it helped to make the right angle. So we get to name that leg either A or B, and it doesn't matter. Whichever one floats your boat for this problem. I'm going to go with A. So here's our task. I don't know what that A is, but I have to square it and add it to the other leg squared. So you're going to see A squared plus 3 squared and then set that equal to my hypotenuse squared, which means 7 squared. So on this problem, our missing side is one of the legs, not the hypotenuse. So the style in which we solve this is going to be a little bit different. Let's clean it up. 3 squared is 9. Oops. Where's my whiteout? I had an oops. Let me fix that. 3 squared is 9. I should have a plus sign in front of that. And 7 squared is 49. So in this problem, we have to solve for a squared. This situation requires us to subtract off the 9, and we'll have a squared equals 40. But we're not done yet. So I'm going to pause. I want to know what questions you guys have on setting up the Pythagorean theorem equation and then slowly getting a by itself. Okay, we now need to take the square root of both sides because that square root removes the square. We'll get a equals the square root of 40. And we're not done. We have to see if we can break this down. Let me zoom out. How's that? Okay. Can you guys give me two numbers that multiply to make 40? We can do 2 and 20 or 4 and 10. 2's prime. Okay, I need two numbers that multiply to make 20. 2 and 10. And two numbers that multiply to make 10. 2 and 5. So I'm going to clean this back up. We have a triple set of 2's and a 5. Out comes a 2. Inside stays the 2 and the 5. We have 2 root 10. And we just found our missing side. Okay. So, in-person people, do you guys have any questions for me on this? Okay. Zoom people, I'm going to pop into the chat in just a second. Would you let me know if you have questions? If you don't, would you tell me no questions so I know that we're good? In-person peeps, you guys okay if I blank this for a quick sec? I can bring it right back.